All right, hi. I'm Nick Arsted, and I'm a mentor for Team 2220 Blue Twilight out of Eagan, Minnesota. And tonight we're going to talk a little bit about sketching. This is going to be a little bit different from the previous videos where we were really focused on a specific design. This one is really meant to be a primer on good sketching techniques in Onshape and some of the useful things that you kind of have to dig through some of their documentation to find. Um, so First off, let's just open with the shortcut for sketching. So the shortcut for sketching is Shift S. So Shift S opens up this sketch box. Really nice, quick way instead of going up there and clicking the sketch thing. Um, And here's where I find a lot of new people just get totally stuck. They're like, okay, what do I click? Um, well, you click a plane, or you click a face on an object that you made. So in this case, I'm going to click the front plane. One of the things I want to mention about selecting plane is that um, the plane you select really does matter, right? It communicates a design intent for your sketch, right? Sketching this on the front um, implies that the part that I'm going to be modeling, or the sketch that I'm going to be modeling, that is the front of the sketch, right? You want to sketch things on the planes where they make sense. So if I really wanted this to be a top-down view, I would click on this sketch plane and then select the top instead, right? It's easy to switch between those two. Um, but it's something that you should really keep in mind when you're doing things, because if you don't, then you can make something that's confusing for you in the future, or confusing for somebody else. And adhering to those standards makes it easier when you bring the parts that you model from your sketch into an assembly or something, because they're in the correct orientation. Um, and really, this is going to be a running theme in this video, is talking about design intent. Design intent is uh, how you communicate that design intent, your intentions for the design through your CAD drawings. CAD is a communications tool, um, and you need to keep that in mind first and foremost when you're modeling things. Um, so we switch this over to a top view. We're going to name this, right? We're going to name this. So typically, the first sketch that you make will be called the master sketch. Uh, Master refers to the fact that it should control the geometry that comes after it, right? So this should be the key geometry of your sketch. Um, I'm going to flip this back to a front because I'm going to draw like a semi gearbox like thing to illustrate some of these points. So we got that. Another useful shortcut from sketching is the N tool, is the N key. So U normal 2. Um, that could be really nice. One of the things that you'll notice when you're working with a larger assembly is sometimes this plane, you want it to be a little bit larger because it makes it easier to grab or something. So if you do that, you can click on that sketch plane and then click these little handles to drag it around. That can be really useful. Notice I'm still in a sketch. Um, you don't want to press that green check mark until you're done with the sketch, or you'll exit the sketch uh, to finish things off. You want to deselect things, click somewhere else. Um, so one of the most common things that I see with newer designers in CAD is that they'll do something like I'm about to do. So they'll say, I want to design a gearbox, right? There's a core bearing um, and that has the output shaft. They'll take that and they'll start sketching up over here somewhere, right? Um, they'll start trying to sketch out here. They might put their mounting holes somewhere out here, right? Say I want 6 mounting holes. So one of the things I'm using here is called implicit constraints. That's when I mouse over this and then I move it's out there and can see that orange line. Um, and they'll be like, okay, so I want these guys to be all different. So maybe I make a line between these. Actually, so I'll make a line between these guys. And then I do that, right? So you end up with this gearbox thing that's over here that is in a position that doesn't really make sense for a gearbox. And then I can drag these all around, and since everything's blue, everything's screwed up when I drag things around because I didn't constrain things. Um, so this is kind of the second key point of this video, right? Is if you see blue, you made a you either made a mistake or you're not done yet, right? If you have a complete, quote unquote complete sketch, but you see blue, it's probably not complete unless you're sketching like for a depth, whatever, some geometry to like see what an arm looks like or something. Uh, which will be another video, is talking about how you do some of those like base level design things, um, whatever overall design sketches. So in that case, instead of doing that, we can do something different, right? Which is constrain that on the origin, right? These planes are here to be useful to you, right? If you want something in the center, that's meaningful, you want that center to be meaningful, right? So in this case, I'm going to make it that output shaft because that's a meaningful thing to be in the center, right? And putting it in the center, putting it on those things will let me use these planes that you can see here to take advantage of symmetry in the design. Um, that'll let you do things faster. That lets you make things more flexible down the line. Just generally a good call. Um, all right. One of the things I also wanted to mention, right, is something that you've seen me doing here. So I'm going to go up here. I'm going to grab a circumscribed polygon, which is a really great, easy way to represent like a motor mounting pattern. So make one of those out here, and you can see I can change it between 4, 6, whatever, right? Click that again to release that. So this is a 6 times this is a hexagon, right? Uh, but you'll notice this is a solid, right? So if I were to exit this with an extrude, um, Onshape would assume that I want to make a hexagon somewhere, but that's not really the case. In this case, I really care more about these points than I care about anything else. So what I can do is I can drag a box over this and then hit Q. Um, Q toggles whether you're in construction geometry or not. Construction being the dotted lines, right? So that's a very useful thing to do sometimes. Um, so, and then in this case, I maybe want these to be vertical, so I can select these 2 points and then click vertical. I could also say, click this line and say that's vertical. All valid things to do. Another really valid things to do is to use implicit constraint. So in this case, simplest implicit constraint is I move over a point and it turns orange. If it's orange, then Onshape is going to, when I click something, it's going to make it on that point, right? Another note that I don't think I mentioned earlier, right? So if you see that box, don't click the box, right? Clicking the box, enter something else. Um, Instead of clicking the box, just type. So if I want this to be a 0.75 inch thing, I can just type and make that 0.75 inches. Um, just like that, right? So much easier than clicking that or trying to dimension it afterwards. Onshape is typically pretty good about what those default dimensions are. So since this is a gearbox, I'm going to draw a couple more construction circles that are going to represent the gears, right? So if I wanted this center one to be a 60-tooth gear for a 60-tooth 20 diametrical pitch gear is going to be 60 divided by 20 inches in size. And then if this is a 10 diametrical pitch 10 tooth DP gear, it's going to be 10. And if I want those to be a distance between each other because I'm making a gearbox, right, and I have a little adder here, I can just dimension between those two, make that 0.003, right? And I accidentally I haven't dimensioned this circle yet, so that, another reason, right? This is why we dimension our circles. So since this is probably a falcon, I can make that a 2-inch circle, and that looks right. Now, why are some of these things still blue? So you can always find out why something's blue by clicking it and dragging it, right? So in this case, it's because this guy, when I made that, I didn't constrain it to the center. So I can drag this down, I can move it over to the orange, and now that's fully constrained. So that is really nice. If I wanted to undo that, right? So if you notice, if I mouse over here, you can see these little boxes, right? So these represent constraints. They correspond to the constraints up here, right? Same constraint symbol is what the constraint looks like down here. So if I wanted to undo that and I wanted to not be centered on there, I could click that constraint and delete it, right? And now I'm back in that previous state. Not quite the same previous state, right? Because I made it constraint equal to that. So you can notice, right, when I do this, there are a couple of these. So there's this one, which corresponds to those two circles because it's highlighting those. And then there's this one, which is that center circle and the origin. So you can click those and delete those whenever you want, right? Sometimes that's really useful. I'll talk about a situation where that's really useful later in this video. Uh, so Onshape, you've been noticing I've been doing a lot of hotkeys. Onshape has a really great hotkey menu that you can open up. Always check these. So I just did Shift question mark. That'll open up this hotkey menu, right? And you can always check what the hotkeys that you could use are if you forget them. I recommend getting used to the hotkeys. They just make your life a lot easier. They make things a lot faster to go and use those hotkeys. All right, so let's take advantage of a couple of things that we did so since we made this all centered on here, I'm still going to want these points over here. Maybe I want some other geometry. I want bolts to hold this gearbox together somewhere out here. So this is another kind of implicit, right? Which is I moved over this and then I'm moving out. And you can see that orange dotted line, right? So that's going to be somewhere out here. The overall diameter of this is about, say it's 2.5 inches. It's not quite because it's a falcon, right? So we'll say we want this guy to be whatever the nearest single inch increment is. And that is another thing that you can do, right? You can toggle between construction while you're making something. I'm going to drag that out to this point, right? And we can see that that's a 6.5 inch, maybe. So I want 1 inch or something like that. Looks too big. 0.625 maybe. Cool. So I'm going to want the largest version of this possible. It's a 1/2 inch increment. So let's say 7, probably. Okay. So that's, other than the mirror that I'm about to do, that's almost the entire construction geometry that I would use for this. So for mirror, click the mirror button, select that plane, and we can drag over all this to mirror those. And then the nice thing is, right, is down the line, I say I wanted this to be 12 instead, right? You can see it affects both of them, which makes a life much easier. All right. So that's what I would call a good master sketch, right? It has our gears. It has our motors in 2D. It has some of those key points on this. Actually, it's missing one key point, which is, so if we're going to make this a, if we're going to make this connect to like a standard West Coast drive gearbox plate, this is going to need to be like, you're going to have a couple of holes on a 1.875-inch pattern here. And then I can mirror down the line here, mirror that point. Yes, it would absolutely, I could absolutely just make a point over here. That would be fine. Mirroring this is nicer. It's nicer for that future adjustability if I wanted to change that 1.875 inches or something like that. Just useful to take advantage of mirrors. So that's our master sketch. And here, and then I'm going to use this to introduce you to a couple more useful tools here. So I'm going to make another sketch now on this front plane, and this is going to be called gearbox body. And we'll hit end to that. And what we're going to do is we're going to use the key geometry from this. So I'm going to use this, use these points. Right. And that was using the use key, right? So you hit the U button and you enter the use tool, which lets you, it's equivalent to the project geometry and some other CAD programs. It's just, it's useful, useful to do. So this, yeah, that'll work probably. Actually, that won't quite work. So nice thing is, so I did this first sketch, what I would consider a little bit wrong. And this is where you'll get to see some of that benefit of the master sketch technique. So let's hit use again. And then we're going to use these, and we're going to use the offset tool, or O, to offset a few other things. Sometimes you have to click the arrow to flip it around on offset. And we're getting close to some geometry that we'd like. So now I'm going to do is I'm going to actually intentionally avoid some constraints here. So you'll notice I'm dragging this around. I'm being a little bit careful about how I do it to avoid being tangent to something that I don't want it to be tangent to. I really just want it to be coincident on these. And then what I could do is I can go back later and I can say, all right, I want this to be tangent here. I want this to be tangent here. Tangent here. Tangent here. And then I can use those mirror tools again to make my life easy. And this is why I really emphasize you stick with that center piece. It makes your life easier. Cool. And then this is going to be really nasty. A little bit of a nasty thing. So you have to click these sections that it accidentally grabbed. I'll change this to a 1/4 inch there. One of the things you'll notice I did there, right, is I used Shift E to extrude that, which is nice. Okay, so I've got this, but we'll notice here, right, so one of the issues I made, right, I have here, and we may or may not see this. Let me pull in a Falcon motor to check. I think Falcons are slightly smaller. I'm going into the Okay, I had to grab that. So what's this? This dimension. 1.181 is that outer diameter. So that means I'm going to go back into here and I'm going to say so this 2.5 inches. If I do that, it's really more like 2.36 or so, which still leaves us with that. So then those guys all update too, which is great. This gear spacing also looks like it's going to leave this interfering with a bearing flange out here, which we could do a few different ways, but for simplicity of assembly, I'm going to flip that around. So maybe I want this to be, instead of a 60-tooth gear, let's flip that up to 62, maybe 64. Like anything in CAD, there's different ways to go with this, but this is one way. So now you notice that messed up that second sketch a little bit. That's fine. You just go back and we select these things, and that'll fix it. Doing it this way also gives us some benefits. So now we can just use those points directly for our holes. Just not make that a countersink. And those are probably number 10 holes. And then let's see how Onshape feels about me just giving it that. It's not a fan. So we'll select them manually. So I'm gonna select those. Again, point isn't that this is a perfect gearbox design. The point is to talk about how to use sketches effectively. Cool. Right. We have something roughly approximating a gearbox plate. For a little bit of fun on top of that, we can play a little bit with one of my favorite fun feature scripts, the Lighten feature script. The way Lighten works is that you give it some sections. And I'm not gonna, fine, we'll rename that just because. Then you go into Lighten, you say, Lighten this thing. And it will do nonsense things, like leave you with no material if you tell it not to. If I move this to something more sensible, like 1/4 inch, right, it'll give me more sensible lightning holes. You can change radiuses on stuff, all that fun stuff. I typically leave lightens just named as they are. So that's a quick one. Just for, because I want to cover it, I also want to talk a little bit about patterns in Onshape. So sketch patterns are really powerful. So if let's say I am back in the dark ages without the tube feature script, and I want to create a tube that's at an angle. That might not be the best place to start. So let's just first introduce the linear pattern. So this to be 0.196 hole. That's a number 10 size hole, and I would just want a linear pattern that. See, it just gives me those patterns. So let's make it 8 or something like that, right? Then I can click that and I've got a whole pattern that's super powerful. That. Now, what if I want this to be at an angle though? What we could do is you can use that deleting constraints thing to just break this up. Because all of the Onshape base geometry actually uses those same constraints. So you notice that if I do that, right, I can get these guys off skew, which might be desirable, might not be. If it's not, we can make these lines perpendicular. And then we've got a pattern that can rotate like that. Something else we might want to do is something like I've got a bunch of these holes in a circle around here. I can use the circular pattern, which is a little bit weird, but works pretty well. Mess that around. Notice these are all unconstrained because in this case, that center of that circle is constrained. So I can say I want this to be on this guy out here. It can give this a dimension like 45 degrees. All that fun stuff. In this case, this is why I don't typically use circular patterns, because most of the time a circular pattern can be done with most of the times I would use a circular pattern, I would use an inscribed polygon, a circumscribed polygon, which sometimes maybe you don't, but nothing's concerning that, right? And that's kind of patterns. That about covers it for tonight. Let me know. Feel free to reach out to me on Chief, Discord, wherever, with any questions. I love talking about CAD. Until next time.